Welcome back. Today we will be talking about evaluating limits, and this is the removable discontinuity. So as you can see in the very first question, they are asking you as a limit x approaches to 2. If you see on the graph, x is approaching from the right hand side and to the left hand side, and it is nothing but a negative 2, though it is an open circle. Can I evaluate it algebraically? Let's try. So here's the thing, the limit is trying to reach 2. It is not at 2. So we cannot take the second function. We will take only the first function. So f of x is negative x squared plus 2. And when you apply the direct substitution, it will be negative 2 squared plus 2. That will also give you negative 2. So either if the graph is given, you can look at the graph and see, or you can evaluate algebraically as well. Question number 2 will make sense if question number 3 is easier for you, because question number 3 covers question number 2 and 4 both. So if in this one we will factor it first, because if you apply the direct substitution in this case, it will make the denominator as 0, because 3 minus 3 will be a 0, and when we have a denominator as 0, then it becomes undefined. So to avoid that, what we will do, we will factor the numerator first. And don't forget to write limit as x approaches to whatever number it is. You can drop the limit symbol when you are ready for the direct substitution. So this will be the factoring part, and from here we can cross off x minus 3. So this implies there will be a hole in the graph at x is equal to 3, right? That is a hole. So when we will graph it, we know that we need to have a hole at that point, because we are basically putting x minus 3 is equal to 0. Now what is left? Left is x minus 4. At this point, we can do the direct substitution. And when you do the direct substitution, there is no need to write the limit again. So 3 minus 4, it should be negative 1. So I know the answer is negative 1, but this question is also asking for the graphing. So how to graph? So whatever is left after factoring it out, that is my equation of the line. That means x minus 4. Right? So we will take that as the basis to graph. So if we are graphing that function, so negative 4, that means b. So coordinate is 0, comma, negative 4. That means on the y-axis, we can start at negative 4, or that is the intercept. And for every x value, we are getting one y value. But remember, we will have x at x is equal to 3, we will have a hole. So this is how, I'm just sketching the rough graph. This is how the graph of the function should look like. Keeping this as the base, you can solve question number 2 and 4 as well. Let's try another questions. So number 5 and number 6, they are piecewise functions. And when we solve piecewise function, we need to consider the different domains. So in number 5, it says limit x is approaching to 0. Now it is approaching to 0, it is not at 0. Because it is not at 0, we cannot take the second function. The only function that is applicable in this case is the first function. So we can say f of x is equal to x plus 1. Right? So that will be 0 plus 1, which is nothing but 1 is the final answer. Same way you can solve question number 6. Let's go to the next page. Because KutaSoftware gives you the answer, but it doesn't give you the detailed explanation, and sometimes we get stuck. So from 7 to 10, you can solve it just by factoring as we did for question number 3. Because if you do the direct substitution first, it will result into a 0 as a denominator. For number 11 and 12, if you look up closely, we have a denominators, right? In the question number 11, we have a denominator in the numerator, and in number 12, we have a denominator of a denominator. This is how it works for me. I always rhyme whenever we have a denominator of a denominator, it becomes the numerator. It is nothing but, it is just the reciprocal of it, right? So denominator of a denominator will become a numerator. So let's try to solve it. So first we can solve the numerator first, because numerator is itself, it is a fraction, two fractions added together. So we will take the common denominators, because whenever you add the two fractions, you need to take the common denominators. If we solve it further, we have 4 minus 4, so that will be cancelled out. And in the denominator, we have negative 16 plus 4x. So now let's combine everything together, the numerator part that we just solved and the denominator as well. So that will be x, negative 16 plus 4x, and everything times 1 over x, because x is in the denominator. If you simplify it further, x and x will be crossed off again. So we will be left with 1 over negative 16 plus 4x. But don't forget to write the limit notation, because if you don't write the limit notation, your teacher might deduct the points. So if you do the direct substitution in this case, because x is 0, it will be nothing but negative 1 over 16 plus 0, which is negative 1 over 16. When you are ready for the direct substitution, you can drop the limit notation. But before that, don't drop the limit notation. Please keep on writing the limit notation. I know sometimes it is annoying, but you have to write it. In the same way, you can solve number 12. Now, 13 and 14, they are related with the concept with conjugation and rationalization. You know this stuff very well. You have done it in Algebra 1, Algebra 2, and pre-calculus as well. Or you have done in Accelerated Algebra 2. So, let's try number 14. We will multiply with the conjugate. So I will just change the sign from negative to positive. We will multiply with the conjugate in the numerator and in the denominator. If you solve it, and yes, don't forget to write the limit notation. So the numerator will be radical x plus 6 squared minus 3 squared, because it is the same property of a plus b times a minus b, which is nothing but a squared minus b squared. So you need to have your properties quite handy with you, right? So x minus 3 in the denominator times everything, which is radical x plus 6 plus 3. Let's clean this up. So in the numerator, if you square it, you will get limit as x approaches to 3, x plus 6 minus 9, and we will write the denominator as it is for the meanwhile. Why I am writing the denominator as it is? Because when you solve the numerator, there will be some equation that can be cancelled out. Let's write it again. So limit x approaches to 3. Now we have x minus 3 in the numerator, and you can see you can cross it off from the denominator. So unless and until you are able to factorize everything, don't get into the temptation of solving the denominator, right? Keep on writing the denominator as it is. And after this, we can just do direct substitution, so there is no need to write limit notation again. So we will say 3 plus 6 in the radical minus 3. That will give you 1 over radical 9 minus 3. It should be minus 3. I wrote plus 3 by mistake. So that should be the answer, because it is radical x plus 6 plus 3. It is not minus 3, it is plus 3, because we did with the conjugation. So answer is correct. 1 over 6, that is correct. For number 16, we can put the denominator equal to 0. So that will give you x is equal to 2. That is my restriction. And the another restriction will be a 0. Why 0? Because when x is 0, we will get fraction 1 over negative 2 plus 1 over 2. That is nothing but a 0, right? So these are my restrictions. So a cannot be equal to 0 or 2. It can be any other number and the answer will be done. So again, in question number 14, it is radicals x plus 6 plus 3. Thank you for watching, and I will see you in the next video.